Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our Chemistry 11 content. What we're covering today is going to be a continuation of the gas laws. We're going to move on to the next law, which is Charles's law. Okay, I'm going to write down the equation on the board. Okay, so this is Charles's law. So let's put V1 over T1, okay, equals V2 over T2. Okay, so just like this. Okay, and what you're doing for Charles's law, okay, is it directly relates the volume to the temperature. The temperature must be in Kelvin, okay, for the gas. Okay, so let's write down what it means. So let's put where V1, okay, and V2, I'm going to put represent, okay. What it represents here is basically the volume. Let's put the initial volume, okay, as well as the final volume, okay, of the gas that you're looking at. Okay, so remember this unit is all about gases, okay, where you're looking at the T1 and T2, okay, represents, let's put T1 and T2. Okay, this represents basically the initial and the final temperatures of the gas. Okay, so initial and we'll just write it over here, okay, the final temperature. Okay, and it has to be in Kelvin here, okay. The volume, okay, should actually be in liters. So let's put liters here. Okay, and that way when you're using the equation, you can see the equation is very simple. Okay, in this case actually for Charles's law, the pressure has to be kept constant, and then only can you relate the volume, and the volume here is directly proportional to the temperature, which means as you're increasing the volume, the temperature of the gas should also increase. Okay, so with that, let's try this example from the textbook. Okay, so I'm just going to take this off. And again, when you're doing any of the gas laws, make sure you are writing down what is given, and that makes it very easy to actually solve for the unknown value. Okay, so I'm going to read out the question here. So using a glass syringe, a scientist draws exactly 25.5 centimeters cubed of dry oxygen at 20 degrees Celsius from a metal cylinder. Okay, so let's write down what's given here. Okay, so it looks like what I'm given here is the initial volume. Okay, so I'm going to put, let's put V1, okay? So again, in some textbooks, they might use VI and then TI, which is the same thing. It's just the initial volume and temperature, okay? So I'm going to put 25.5 centimeters cubed. Okay, and the initial temperature is given as 20, okay, degrees Celsius. So I'll put T1 equals 20 plus 273, okay? So one more time, make sure you are adding it to 273. And this is going to change it into Kelvin. So 293 Kelvin, okay? All right, so she needs to heat the oxygen for an experiment. So she's placing the syringe over in an oven at 65 degrees Celsius. Okay, so this is going to be my final temperature. So I'm going to put 65 plus 273. And it's easier also when you're writing the given values. Make sure you're just changing the temperature into Kelvin right away. Okay, so we're just going to add that together. We're getting 338 Kelvin. Okay. And it says assuming that the atmospheric pressure stays the same, so the pressure has to be constant here, like I said, what volume will the oxygen occupy? Okay. So here you could just write down what's required here. Okay, and I'm looking for V2. And as soon as you write this down, okay, it's very clear what you are solving for, okay? So one more time, because the volume, okay, is given in centimeters cubed, it is okay if you want to leave the volume the same. Okay, make sure when you're solving for the final volume, you write down the exact units, okay? So the units will not be like liters here, okay? As an aside, if you want to just write down 1 centimeter cubed is equal to 1 milliliter, okay? This is a conversion factor. It's not directly changing it into liters. If you do need to convert it, or the question asks you to convert it, then make sure you're using this conversion factor, okay? So let's plug this in. So we're going to put V1 over T1 equals V2 over T2. Okay, so just like this. And then we're going to just plug in the values that we are given here. Okay, so I'm going to put 25.5 for V1. Okay, over 293. And that's going to equal to V2 because we're looking for V2 here. Okay, and over T2, which is 338. So we're just going to write it on this side right here. Okay, so what you're doing now is I'm going to cross multiply to get my answer. Okay, so let's do V2 equals. Okay, so again, when you are cross multiplying, make sure you just multiply the numbers that are across from each other. So we're going to do 25.5. Okay, and then times that by 338 divided by 293. Does everyone see that? Okay, and we're going to just use our calculator and plug in the value here. Times 338 divided by 293. Okay, and we're just going to round it to 1 decimal place because the initial volume is also given to 1 decimal place. Okay, so we're getting 29.4 centimeters cubed. Okay, does everyone see how to do that? Okay, good. And so one more time, I'm not going to write liters for my final volume here. This is in centimeters cubed. Okay, so with that, okay, let's try one more question. And every time you do these questions, okay, I would just use the crossover method, okay? The textbook might show you a different method to calculate the values. Okay, and there's really no need, okay, to use different methods for this. Alright, so let's try this example. Okay, so let me just take this off. And I'll keep the given and required, okay, because this is the method that you should be using, okay, every time you're solving, okay, this question or these types of questions. Okay, so let's read this question out loud. Okay, so a balloon is filled with 2.5 liters of dry helium at 23.5 degrees Celsius. So let's write down what's given. So I have V1 here is 2.5 liters. Okay, and the initial temperature is given. It's 23.5 degrees Celsius plus 273. Okay, and the teacher will always, just because we use degrees Celsius all the time, okay, I have to make sure I convert that to Kelvin. So we're getting 296.5 Kelvin, okay? I don't want to actually round this, okay, until the very end. So I'm just going to leave this value here. Okay, so the next morning, the balloon is removed and the volume is found to be 2.15 liters. Okay, and let's just write it here. So this is the final volume. So let's put V2. So 2.15 liters, okay. What is the temperature in degrees Celsius inside the freezer if the pressure is remained constant, okay? So it looks like we are looking for the final temperature, which is T2. Oh, sorry, we'll just write it over here actually, okay? I would write the required separately, okay? Just so the teacher can see what you're solving for, all right? And we're going to plug it into our formula. So let's write out the formula right here. So V1 over T1 equals V2 over T2. Each of these formulas that we're going through, you should memorize all the formulas. It's not going to be given on a quiz or a test. And what's also important is that you remember the person's name. So this is Charles's law. And I should remember the formula. It's V1 over T1 equals V2 over T2. Especially if your teacher gives multiple choice questions. These are the types of questions that they will give you because they expect you to remember the person's name and then the law that they came up with. Okay? Alright, so let's plug in our values here. Okay, so V1 is given as 2.5 and T1 is 296.5 K. Okay? And we're going to make this equal to V2 this time, so 2.15 over T2, and I'm looking for T2 here. Okay, so just like this, and we're going to do it on the other side of the board here. Alright, so I'm going to again cross multiply. So I'm going to put T2 equals, and you're going to multiply these two values, okay, this time. So you're just multiplying the two values on the opposite sides of each other. Okay, so I'm going to do 296.5 times 2.15. So when you cross multiply, you multiply the numbers on the two opposite sides, and then you just divide by that third number. Okay, so I'm going to divide this by 2.5. Okay, put this into your calculator. So 296.5 times 2.15 divided by 2.5. Okay, and so here we are getting, so I'm just going to round that to 255, okay, Kelvin. So what we're getting as an exact value here is 254.99, okay? So it is okay if you want to round this, okay? The teacher shouldn't take off a mark for that. Okay, however, note that the question was saying what was the temperature in degrees Celsius, okay, inside the freezer. So I can't leave my answer like this in Kelvin. What we're going to do is just subtract, okay, 273. Okay, so you could just put minus 273 here. Okay, and it's going to be equal, okay, to negative 18, okay, degrees Celsius. So I'm going to put negative 18, okay, degrees Celsius. And this is basically your final temperature, okay, in degrees Celsius. And remember, the value has to be negative, okay? This is basically like below zero, okay? And the temperature inside the freezer has to be very cold in order to keep everything frozen. Okay, so your answer should make logical sense as well, okay, as you're checking it out. Make sure you're not getting any kind of positive value above 0 degrees Celsius. All right? Okay, so that looks good. And I hope you did learn how to apply Charles's law today. This is very important. Make sure as you're going through the textbook, you're doing a lot of practice questions and you have a very firm grasp of all of these different laws that we're going through. Okay? Alright, so that looks good, and that brings this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I'll see everyone in the next video. Thanks, bye.